me on the way that I took the picture, but this is improvised, okay, so I hope it helps. So yesterday we did long division and synthetic division. For those who were not here yesterday, for long division, at the end, I'm going to come back and just go over one problem that is long division, okay? As for right now, we're going to continue with number 5, which is use the remainder theorem. All you got to do is use synthetic division, and then whatever the remainder is, that's the answer to the problem. So in this problem number 5, it says find the remainder when f of x is divided by x minus k. So all you have to do is use synthetic division. So I get the coefficients, which is 4, 2, and 5. Do a little box. Now in this case, when it says k equal, in this case, when k is equal to 1, they already tell me, that x minus k equal to 0. So they're already telling me that x equals to k. And since k is equal to 1, then that's going to be the number that I'm going to use to divide this by. And that would be 1. And then from here, all you got to do is bring the 4 down. You always bring the first number down. Then you multiply. 1 times 4 is 4. 4 plus 2 is 6. 6 times 1 is 6. And then the last part, which we already know, we just combine it, that's 11, and that's the remainder. So the remainder, which is r of x, remainder, is 11. And that's the answer. Okay? We do the same thing with number 6. They just want the remainder. Now, something that I need to make sure, you check is the exponents. Make sure that you have the exponents from highest degree all the way to x to the 0 power. So the second one, number 6, is also already set up because I have 3, 2, 1, and then x to the 0 power. So it's already set up. It's ready. So I get my coefficients, which is 3, -6, -4, and 12. And this is divided by k, which is -2.
Which would be positive 2.
No, because
we're gonna do the
remember,
opposite now?
when you solve for k over here, x minus k equal to 0, x is equal to k. So since you're saying that k is -2, that's what you use outside, okay? And then you divide. Again, you bring the first number down, then multiply by the divisor, which is -2, and that's -6. So -6 and -6 is -12. -12 times -2. -12 times -2 is positive 24. And then positive 24, -4, it's 20 times -2 is -40. Put the little box indicating that that's going to be the remainder. 12 minus 40 is -28. So the remainder, r of x, is -28. And that's all they're asking here. Yes, so it's kind of easy, I hope. Yes.
Are we going to be able to use a...
Yes, you're going to be able to use the 4-function key calculators, not the graphing ones, yes. Because when you use a graphing calculator, you can get all the answers right away. No big deal, without doing anything. So, no, you cannot use the graphing ones, only the 4-function keys, okay?
But on the 4-function keys, you can't put negatives, right?
That's something else that if you have another calculator, because those are the only ones that the school has. If you have a non-graphing calculator and you want to bring that one, that is scientific calculator, has a negative and positive and stuff like that, by all means bring it. Okay. The problem is when it's a graphing calculator. Okay.
Like the ones that they have in like physics and stuff, like those are
Right. Yes. The ones for physics that is not a graphing one, those are the ones that you can bring. Okay. Okay. So let's go ahead and move on to the next. On the back side, it says, use the factor theorem to determine whether the first polynomial is a factor of the second polynomial. Well, please put a little note here. Put a note that input here that if r of x, in this case r of x is the remainder. If r of x is equal to 0, then the first polynomial is a factor of the second one. Okay, so we need to, again, divide by synthetic division. You can do it by long division, but it's easier to do it by synthetic division, okay? So we divide. In this case, they're giving me the factor. This is x minus 3. So when I solve for x is going to be what? X minus 3 equal to 0. X is going to be positive 3. That's right. So that's going to be my divisor. I divided by 3. And then I check to see if the factors, the terms go from highest to lowest, and they do, right? It's 3,
Five.
2, 1, 0. So it is in descending order.
Oh.
So now let's go ahead and put the coefficients, which is 5, negative 27, 36. Put a line. Then bring the first number, 5 down. 5 times 3 is 15. You subtract, and that's negative 12. 3 times negative 12 is negative 36. Negative 36. And when you combine that, that is 0. Yes. So you combine it. Come on. It is 0. So since the remainder is 0, then x minus 3 is a factor of the second polynomial. Okay. Any questions on checking to see if they're factors? So far, so good. Okay, now go ahead and try number 8 and try number 9. And determine if they are or they're not factors, please.
Miss, so we
On the quiz, are you gonna give us problems when the numbers aren't in order?
Yes.
There.
It's gonna wake up again so you can burp it. Miss, 8 times negative 4 is 4. Or you just bring down the 8.
You just bring down the 8. Yes. So check your answers. Did you get for number 8 that it is a factor? Because the remainder is 0. It was 8 times negative 4 is negative 32. When you combine them, it's negative 3. Negative 3 times negative 4 is positive 12. When you combine them, that is 1. 1 times negative 4 is negative 4 combined, and that it was 0. Then for the second one, the factor is x plus 2. So x is negative 2. That's a divisor. 3, 2, 1, 0. So it's in descending order. 6 goes down. 6 times negative 2 is negative 12. Negative 2 times negative 2 is 4. Negative 1 times negative 2 is 2 combined, and that's 4. So if the remainder is 0, it's a factor.
It'll always be.
But if it's not a 0, then it's not a factor. In this case, number 3, number 9 is not a factor because the remainder is 4. Okay? Now, for problem number 10, it says use the graphs to guess possible linear factors. So the graph is actually telling you what some of the factors are going to be. If you look at the graph goes exactly through 1 and through negative 3. So I already know 2 of the factors. The third one, since this is a cubic function, this is 5x to the third power. I'm expecting to have at the most 3 answers. And if you look at the graph, it passes through the x-axis 3 times. So those are the 3 zeros. So what you need to do in something like this is, first of all, get the factors that are whole numbers. Okay, so for example, I have one here, so that's one of the factors, x equals 1. You have another one at -3. And the other one, it's an approximation. It should be something like
7, -7?
between -4 and -5.
Oh, not the ones at the bottom?
That's a y-intercept. The zeros are the ones on the x-axis. So it's only -1, 3, and somewhere between -4 and -5. So this one, I'm going to have to find it through synthetic division. So what you need to do when you're looking for the zeros is you're going to go ahead and get the polynomial and check to see if you have the terms in descending order, 3, 2, 1, 0. So that is ready to be used. This is 5. You get the factors. 33, 31, -69.
What's your outside number?
And the outside number, we can start with the first one, which is x is equal to 1. See, I'm checking this one. I'm using that first. So you put a line underneath. You use synthetic division. And that would be 5 times 1 is 5, plus 33.
38.
38 times 1 is
38.
38, plus 31 is
69.
69 times 1 is,
69.
and combined with the -69, it's 0. And we already know that it was a 0 and had to be a 0 because it's passing through that number. Okay, that's one of the zeros.
Miss, so when you're like 33 and 5 in there in the middle, you are always going to add?
Use those two.
No, yeah, but like when you're trying to bring it down all completely, you're adding up 5.
You adding what?
You're adding like 33 and 5, 31 and 30.
You combine them.
Okay.
You combine them. If they're the same sign, you add them up, keep the sign. If they're different signs, you subtract, keep the sign of the biggest. Yes. Now, what you need to do next is you need to continue here. With that answer, now we're going to check x equals -3. So we put -3 outside, put a line, we continue synthetic division with the result, and we bring the 5 down. So -3 times 5
It's 50.
is -15. Combined with the positive 38, that should be 23. And then times -3 is
20.
23 times 3.
Oh.
You don't add them, you multiply them, so it's -69. And we already know that that was going to be a 0. Okay? Now, what you need to keep in mind is that the leading term was 5x to the third power. Then the answer, the first answer was x to the second power. So our answer here should be with an x to the first power. So notice that this is a factor that was missing. So x equals 1 is the same thing as x minus 1 because you bring the 1 over to the left side. X equals -3, bring the -3 to the left side, and that is x plus 3. So those are the 3 factors, and you'll find that on B. So on the quiz, it's going to be the same thing. I'm giving you the picture, the graph. I'm giving you your multiple choice, choices to choose from. But I need to see all this work here
Miss, but
to
how
get the
would you
credit.
know?
Okay. Right. We're looking for the factors because they're giving us 2 of them. We're looking for the one that is missing.
Is it because-
Yes. Now, the last part. When they ask you to use rational zeros theorems to write a list of potential rational zeros, what you need to do is you need to use the P over the Q, okay? To find the rational zeros, to find the potential zeros, you're going to use P over Q. And you might say, like, what is P and what is Q? Well, P is the last In this case, the coefficient, the number that is at the end, the one that has x to the 0 power, that is p. Q is the coefficient of the leading term. Okay, so in this case, -8 is p and 2 is q. Okay, so we're going to write all the, first we write the factors. Let me go ahead and just move it to the side over here. So for that problem, what I'm going to do, I'm going to say, well, p over q. What is that? P is -8 and q is 2. So when you list all the potential zeros, first you get the factors of 8. So the factors of 8, -8 would be positive -1, positive -2. Let me see if I can move this. Positive -4 and positive -8. Am I missing any factors for 8? I think those are it, right? And now for 2, the factors of 2 would be plus minus 1 and plus minus 2. And then what you need to do is get all the combinations that you can get from here. So the combinations, let me just simplify that. It would be positive 1 divided by 1. So what I'm going to do, I'm going to get the combinations. 1 divided by 1, 2 divided by 1, 4 divided by 1, 8 divided by 1. So the answer is going to be...
You're only supposed to use the combinings.
What do you mean combinings?
Like the ones that they have in common.
No, you get the factors. You get the factors and get all the combinations that you can have. So all of these 4 numbers divided by 1 and all of these 4 numbers divided by 2. Yes,
Where's
Morgan.
the -8 and 2?
The -8 is the coefficient at the end of the polynomial, the one with the x to the 0 power. And the 2 is a coefficient of the leading term. Okay? So my combinations are going to be plus minus 1, plus minus 2, plus minus 4, and plus minus 8. That is when you divide all the numbers by 1. Then when you divide 1 by 2, that would give me plus minus 1/2. Then the next one, 2 divided by 2, I already have it over here, is 1. 4 divided by 2, that's 2. And 8 divided by 2 is 4. So I already have those on the
Oh,
list.
so you need to write them again.
You don't have to write them again. So this is it. This is the list of potential rational zeros. And if you look at the answer choices, that is B. Okay.
Oh, so they don't have to be in order?
No. In this case, it's in order, right? No, it's not C, it's B. Thank you. Okay, so let's do the same thing with number 12. In problem number 12, we get the P and the Q. The Q would be 2, yes. And P would be -7, yes. So P over Q, it's -7 for P. Q is 2.
It's 1 and 7, right?
That's right. Plus minus 1 and plus minus 7 for the 7 and for the 2 is
1.
plus minus 1 and 2. Then your combinations, let me put them over here.
So 1 times 1, or 1 divided by 1 is 1.
Everything divided by 1, it would be just the same thing. So plus minus 1, plus minus 7. Then when you combine it with the 2, that would be 1/2 and then 7/2. So it's plus minus 1/2 and plus minus 7/2. And that would be the answer. Which in this case is C.
Miss,
Yes.
so, okay, you know how you did 1 divided by 1 is
Uh-huh.
1, and then 1 divided by 2 is 2?
1/2.
Wait, but why wouldn't it be 2 if 1 goes into 2 times?
The 1 is on top, the 2 is on the bottom. That's 1/2. If the 2 was to be on top,
Oh, okay.
divided by 1, that would be 2, yes. Now, the last part, number 13. In problem number 13, and let me just bring this out of the way. Okay, I'm going to get it out of the way. Here you go. So in number 13, what we need to do is we need to find all the rational zeros. And these problems are going to be a little tedious, okay? So it's going to take time. Why is that? Because out of all your combinations, you have to try one by one and find out which is the one that would be a zero, okay? So first, on number 13, I need to get my P over the Q to find out which are the potential rational zeros. So P is 16, Q is 1. So the factors are 1, 2, 4, 8, and 16. And it's usually the first ones, okay? So expect something like that also on the quiz and on the test. When I give you something like this, I usually give you out of the first ones. So when you divide that by 1, it would be the same thing, right? So it would be just those potential zeros. So now what you need to do is use synthetic division and divide the polynomial by each one of those potential zeros. So here, my numbers are going to be 1, -4, and 16. Then I try the first one, which is +1.
Wait, did you
Forget the 8 and 2.
Oh, you're doing the top, never mind.
Right, just the coefficients is 1, -4, -4, and 16. So I start with the synthetic division. 1 times 1 is 1, -3 times 1 is -3, and -4 is -7. That's -7, come up with a 16. What is that? 9. So is that a 0? No. Now I check another one, okay? Now how about -1? So what I'm going to do, I'm going to go ahead and erase this.
So rearrange them if we have.
You can erase it because that one doesn't work. So now let's try -1. Okay. Now if x is equals to -1. Okay, we do the same thing. This is -1. -1 times -1 is 1.
1,
And -4.
3,
-3 times -1.
it's 3,
3 and -4.
4,
-1 times -1. And that would be 17. Does it work?
Yeah.
That's a good point. I'm so glad that you guys are aware and you're awake. Awesome. Okay. So let's go ahead and double check this. If x is 1, 1 times -1 is -1. That's -5 times -1 is 5. That's 1 times -1, -1, and that's 15. So 1 doesn't work, -1 doesn't work. Now let's try the 2.
So we have to go through all of them?
So you have to be an expert in synthetic division. Yes. For right now, we're going to do it like that. Later on, I'm going to tell you about rules that you can follow. I don't want to mix up the rules, okay? So here, we try the 2. 1 times 2 is 2. And you can keep that work if you want to on the paper. You can do that, no problem. -4 and 2. -2 times 2. -4 and -4. -8 times 2. 16. And that is negative. So that is a 0. Now that's one of the zeros, right? What we can do here is continue from here. How many we're expected to have? 3. 3. So we already have 1, yes.
Miss, I need like 3 sheets of paper.
Okay, so you're going to have plenty of paper, don't worry. Now let's try the -2. So I'm going to continue from here, okay? I'm going to use that. -2. Bring the 1 down. -1, -2 times 1. And -2 is -4 times -2. Yeah, and that is a 0. So we already have the 3 zeros. Really? Yes, because once you find 2, the first one is x to the 3rd power. The second one is x to the 2nd power. So this is just x. So the solutions are 2, -2, and this factor here, when you let it equal to 0, and you find x,
Equals 4.
x is equal to 4. And those are the solutions. So solutions would be x equals 2, -2, and 4. And that's the answer. Okay. Any questions on 13? No? Okay. Now let's go ahead and try number 14. Okay. And we're going to split out this so we can speed up the process. But let's go ahead and set it up first. First step, let's find P over Q. P over Q. The factors are, what's P?
-24.
-24, and Q is 1. So here I get my factors. 1, 2, 3, 4, 6, and 8. Divided by 1 is just the same factors, okay? So what I'm going to do is I'm going to split out and I'm going to assign each one of you a different number so we can check and, get the answer faster. So 24 and 12 also, right? 12 is another one that we have to check. 12 and 24. Okay, so let's go ahead and assign it. So it seems like the +8 works. Okay, so we divided 1, -9, 5, 27, and -24. Divided by +8. We bring the 8 down. Yes, because this is the solution. This is the actual solution. So 1 times 8 is 8. -1. 1? Awesome. Okay. So -1 times 8 is -8. This is -3 times 8 is -24. 3 times 8 is 24. And the remainder is 0. And then Lorena found out that 1 is also an answer. So let me just put the line underneath you here. So we bring the 1 down. 1 times 1 is 1. That would be 0. That would be 0. -3 times 1 is -3. And the remainder is 0. Then I go back and I say, well, you know what? This is x to the 4th power. The next one is x to the 3rd power. So this must be x squared. So my solutions, if I have 2 already, 8, 1, what I can do, I can say the factor at the end when you have x squared minus 3, you know that that's going to be one factor. Actually, 2 solutions is one factor. That is equal to 0. So when I solve for x, I move the 3 over. You're going to have x squared equals 3. And then you get the square root of that. And as you know, when you get the square root of a number, when you're solving, you always put plus minus square root of 3. And that's the reason why we couldn't get the 4 as whole numbers, as rationals. In this case, the other 2 was positive, negative square root of 3. So, solutions. X equals 8, 1, and positive, negative square root of 3. So at the end, if it's not a whole number, so then just get the last one and let it equal to 0, and that would be the way to get the answer.